Let me first thank you for watching my videos and being a part of this quality education. In this particular video, we'll discuss optimization. There are three techniques, rather, the algorithm which we had been talking about. We are going to discuss which is the best one for this particular case, apply, and then find the solution. Let us now learn how do we solve optimization problems in general with a specific example. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll discuss another very important question based on optimization. We'll also discuss the algorithm while solving this particular problem. So, in our series on optimization, you'll find hundreds of examples, and we are actually solving them using three different algorithms. Let's read the question first and then discuss the algorithm for the given question. Two factories are located at the coordinates a minus x0 and b x0 with their power supply located at p0h. Find y such that the total amount of power line from power supply to the factories is minimum. So optimization, normally we are looking for maximum or minimum values. Here cost is of concern, so we want the minimum length of power line. So the two factories are located. The diagram is already given to you. Coordinate points are also given. Coordinate points will help us to solve this particular question, and h is the power point p, so which is h units away, right? So let me write down p here as the power point and the two factories a and b. So that becomes the diagram. Now let's look into the algorithm and see what works best for us in this particular case. Well, in case you want to learn from me, feel free to send an email on globalmathinstitute@gmail.com. Our students are right there on the top, because apart from understanding how do we solve a problem, they also understand the concepts about the whole chapter and can solve any problem on the topic learned from us. So this is calculus optimization applications. Great. Now let's look into the algorithm which we have discussed in our videos earlier also. So when we talk about optimization, three methods can be adopted to solve optimization problems. Generally, the algorithm is as follows, right? Okay. So first thing is that we need to identify what is to be optimized. In this case, length of the power line is to be optimized, right? Draw a diagram is already given to us. Perfect. Define related variables given to us. Perfect. Write function in one variable. So that is what we are going to do now. We have to write a function which relates the length of the power line with the given information. And then the next step will be find a critical point which will be equated to 0, and then that is the critical point which we need to test. Now, after this, there are three different ways in which we can show that this length which we have figured out is indeed the least. And for that, we could have one method which is called absolute optimum point. And for that method, we should know what could be the extreme values. The closed interval, right? So for using absolute minimum, we are looking for a closed interval from some point A to B, right? The second is we could do the analysis of the first derivative that will give us for minimum. We are looking for something which is decreasing and then increasing at the critical point. Correct, the derivative, right? So that will give us a minimum. And the second derivative, which is also confirming whether the critical point corresponds to minimum or not, we're looking for the second derivative to be at c greater than 0. So it's concave up, and therefore that will be minimum. You understand? Any of these three methods can be adopted to answer this particular question. I hope it makes sense. Perfect. Great. So now let's begin with our solution. So just now we discussed that we know the variables given to us. And now we need to find a relation which is length of power line. So what could be the length of power line? Well, power line starts with point P, and somewhere in Y it actually bifurcates into two portions symmetrical, right? So from this point, let's call this point as distribution point. So from the distribution points, we have two sides which are same, correct? So we can now find the length. So we'll define let L be the length of power line. So we have defined the variable, right? Now in that case, we have an expression L equals to what? So distance from P to D, correct? So from P to D, that distance plus we want D to A, right? And plus from D to B, right? So that is how it is going to be distributed. Now we know D to A, D to B is same, and therefore we can write this as the distance from P to D plus 2 times the distance from, let's say, D to B. It's good to work with the positive values, right? Now, as you can see, there are a lot of variables involved. Uh, but what major variable is y, right? Where should y be, the distribution point, so that we get the minimum length? So we need to write this length in terms of y. Does that make sense to you? Perfect, right? Okay. So what we can see from here that this length here is y, right? So what is from P to D? Well, from P to D, this length will be h minus y. Makes sense, right? So we can write this L as P to D, which is h minus y, right? Plus 2 times. Now D to B. So as you can see, this length here is x and y and makes a right angle triangle, and therefore this is square root of x square plus y square. Makes sense? Since it is x units away. So we got a relation now. And in this relation, you can see that the value of y changes, others are constant, right? And y changes from where to where? Y changes from 0, right? It could be at the origin, or it could be maximum, will be at h, right? So that is the two extreme values of the y which we have identified. So that means we'll use the first algorithm. That will be very convenient for us. So absolute minimum value is what we will now get. So where y could be from 0 to h, we just need to find the critical point and check the values at 0 as the critical point and at h to decide which length is minimum. Is that okay? Perfect. So you got the relation here. Remember one thing that h and x are constant in this case, right? Only variable is y. So let's differentiate this length with y. Makes sense, right? So h is a constant, so we get minus 1 here, right? H minus 1 plus 2 times square root of x square plus y square will be 1 over 2 square root of x square plus y square, right? And derivative of y square is 2y. Makes sense. So that becomes the derivative for us, which we need to minimize, right? Find a critical point. So for a critical number, this derivative should be equal to 0 for critical point. So that's what we need to now figure out. What is that point at which this, what is that value of x, y for which we have 0, right? So we can now rearrange this equation and then solve, right? So let's move on to the next page. So we have dl dy as, all right, we can just cancel these two 2's, correct? So we have 2y over square root of x square plus y square, right? So we have dl dy as equal to 2y over square root of x square plus y square minus 1, correct? 2y over square root of x square y square minus 1, right? Okay. Now this is what we are equating to 0. So that really means that we get 2y equals to taking 1 on this side and then cross multiplying. So let me do it in a couple of steps. Square root of x square plus y square, right, equals to 1, and then we get 2y equals to square root of x square plus y square, correct? Now to find this value, I'm going to square both sides. So we get 4y square equals to x square plus y square. So 4y square minus y square is x square. So 3y square equals to x square, and y will be x square over 3 square root, correct? So that gives us a critical number. Well, it is plus and minus, but we'll just take positive values since we know y is between 0 to h, right? H is positive from the diagram. So we'll take the positive value. So we got y as equal to absolute value of x, but positive we'll take over square root 3. So that is our critical point. Y equals to x over square root 3, correct? So we got that critical number. If x is the length away from origin, in that case, this point is x divided by square root 3, right? So that is how it is. Now we need to prove that this is indeed a minimum, right? So that means now we need to find the value of length. So length is given to us, as we just discussed, as h minus y, right? Plus 2 times square root of x square plus y square, right? This is this length, correct? Now this length will now calculate for different values. One will check the length when h is 0, right? We'll check the length when y is h, right? And we'll check the length when it is x over square root of 3. So I'd like you to check all the three values and confirm which is the minimal, right? So the question is, find y such that total amount of power line from the power supply to the factories is a minimum. So where should y be? The point D in our case. Is that clear to you? Correct? So this is what we are going to do. So let's now use calculator or otherwise find the values, and the expression which we are going to check is this, right? This is length of the power line in terms of y, right? So it is h minus y plus 2 square root of x square plus y square. So let's now do it on a new page. So first value, we know L is h minus y plus 2 times square root of x square plus y square, correct? So if I put y as 0, right, in that case we have h plus 2 square root of x square, which is h plus 2x, correct? And if I put h as y equals to h, right, we know that y is from 0 to h, and that's why we are substituting these values, correct? And we know that the critical number was for y equals to x over square root of 3. Is that clear to you, right? So if I put h in this, then we get h minus h plus 2 square root of x square plus h square, correct? So that gives you, so now in this expression, what you can do is you can write h square as x square, right? So if you take x outside, 2x, right? Square root of 1 plus h square by x square. Makes sense, correct? So it is 2x times something which is positive, right? So this is greater than 2x. Is that clear to you? The third point which we are looking into is x over square root 3, right? So if I put that, I get h minus x over square root 3 plus 2 times x square plus x square over 3, right? Which is, we get h minus x over square root 3, and here we can take x square common, so we get 2x over square root 3, correct? So basically what we have is 2x minus x over square root 3. Let me rewrite this. Which is basically equal to x over square root 3 minus h. So you see, in this case, this is x over square root 3. Those are approximately greater than 2x. You get the idea, right? So those two are the options which is kind of like this or like this. You see that? And what we really come to know is that this is the best way, where this value is x over square root 3. So the minimal, we know this is least, right? Makes sense. And therefore, we can now write down our answer, which is y is equal to x over square root 3 for minimum length, right? Length of power line. Makes sense, correct? So using this particular method, we have found the extreme value. You can also adopt the other two methods and verify that both works. So I hope it makes sense. Perfect. Feel free to write a comment, share your views. If you like and subscribe to my videos, it'd be great. Thanks for your time and all the best. A request from Anil Kumar. We need your support for quality education worldwide. Anyone, anytime can support us. Every dollar counts. Please contact on the email globalmathinstitute@gmail.com. Thanks. Have a great day.